So Paul, a minute ago we started going on about what is science? As a philosopher, please tell me, what is science?
Yeah, okay. So science was once defined by a famous philosopher as a system of organized skepticism. And I think that's not a bad starting point. There's no strict limit to science. I mean, there are some bits in the social sciences that we might say, well, is history a science? Probably not. But is economics a science? It probably is. What about economic history? Well, who knows? So let's not get hung up on boundaries.
Right.
You could almost say, we know science when we see it, we know non-science, and then there's cases around the edge that aren't clear, and that's fine. So the cases we're really clear about, modern biology,
but
modern physics.
skepticism is at the key.
Skepticism is about not asking, how can I prove to the other guy that I'm right, but what can I do to... I think a lot of science at the most basic level is about, right, I've got this great idea. How can I rub its face in reality and see whether it holds up?
This sounds like what Karl Popper made us all think about.
Yeah, I mean, the details of Popper's account have been, Popper...
challenged big time.
Shown to be wrong technically. But the basic idea that science is about learning, we create structured, rigorously developed ideas where it's very as clear as possible what's being asserted, and we confront them with reality, and the more honest and committed we are to confronting them with reality, the more progress we'll make.
So I have deep disagreements with other scientists about how to go about this. There's several scientists, a physicist, a biochemist, and a psychologist in particular, and they say the right way to do science is like a lawyer. You advocate for your position, you put out all the positions in front of yours that support yours, and you tear down the opposition, and like lawyers, eventually the truth comes out of people battling. I think that's just awful. It seems to me that what we all should be doing is trying to figure out what are all the possibilities and what's the evidence for against each, and where do we come out in terms of...
I think they might be working on the wrong scale. If you're talking about a major revolution in science, we've got two big theories with lots of data supporting them, and we might be useful to have that kind of a battle. If you're actually running a study, you're an epidemiologist, you want to know, I'm going to measure a bunch of people and see whether this cause is producing this disease. The last thing you want to do is to advocate to your,
we see it all
pull
the
the
time,
wool over your
we
eyes.
see it all. The people who study salt tell us salt causes your high blood pressure.
And that's a problem.
Yeah.
They would be better off saying, okay, how sure am I that, and what's more, this is the other problem, of course, and a big and complicated research field these days, a really good research field is, look, maybe the incentive structure of science is giving people too much of an incentive to blow the trumpet of their theory.
And find positive results.
Yeah.
And nobody will publish your results that show something isn't true.
Yeah. The other interesting thing, we were talking earlier about the replication crisis in science.
Yes, right.
So the replication crisis in science, is very practical and very real. And, I think it really is a crisis. People are really worried about that. And that's actually, it's just a happy hunting ground for philosophers. Because, what is it now, nearly 300 years ago, David Hume, perhaps the greatest of the kind of early modern philosophers trying to redo philosophy in the light of the scientific revolution. Hume came along and said, actually, we don't have a rigorous justification for taking a small body of evidence and saying, well, that's how the world works everywhere and every time. We observe 100 animals and we say, and every animal of that species will do it. And Hume said, we don't have a rigorous justification of that. And in the early 20th century, in my view, some of the smartest thinkers of the whole century were the people who gave us modern statistics. Yes. And when I teach a philosophy class, I don't just teach the philosophy students, look, here are the standard statistical tests, believe whatever they tell you. What you try to teach philosophy students is, here's what these very, very smart guys who knew a lot of philosophy said, this problem of how you can get from a small number of observations to general knowledge, here are some very complicated and pretty problematic mathematical ideas. And we reckon, here's my argument for why this test will justify extrapolating. And other guys, as you know, there are competing schools in statistics.
Well, and we have this problem where people think that a p-value less than 0.05 means something is correct.
Right,
and it's just
and that's because statistics is philosophically deep and mathematically complex, and if you think you've understood it because you can use a statistics package, you're wrong. So the thing is, the replication crisis, in my view, reflects something that real theoretical statisticians and the philosophers who work with them have known for a long time, which is that the classical statistical approaches that we use in psychology actually they're not powerful enough to do what we want.
And
we need to be
we are getting
more
better. We are starting to talk for every experiment about how much of the variation is explained,
Yep.
instead of just, is it significantly
and
different?
using there are an awful lot of different kinds of statistics, and the tough problem is that quite a small proportion of scientists are sufficiently trained in the foundations of mathematics and statistics to be able to work out for themselves what would be the most meaningful and effective statistical approach to the problem I'm confronting. And that's no criticism of them. That's a really hard thing to do.
It's a subtle business.
It is, yeah.
Okay. Thank you so much for joining us today.
All right.
Love it.
Yeah.